Okay, now we'll be calculating some p-values. In order to calculate p-values, we have to know quite a bit about this sampling distribution called the null distribution, because p-values are calculated from this null distribution. So the center of the null distribution is the null value. The null value comes from the null hypothesis. In this case, the null hypothesis is that the population proportion of people that want government assistance is 52%. So that null proportion comes from the claim that's being made by this Fox poll that the proportion of Americans that want government assistance is 52%. So since that's in the middle, we go out and we calculate, we collect a sample of 40 Americans and we calculate what's called a sample statistic to estimate the population parameter, which is the proportion. The sample statistic we got was that out of the 40 Americans we sampled, 15 of them said they wanted government assistance, which is a proportion in the sample of 0.375. That is called the sample proportion. That is the sample statistic. So what the p-value is, the p-value is the probability of getting a value in the sample at least as extreme as whatever your sample statistic is. So if the actual population proportion is 0.52 like we've assumed, what would be the probability of getting a proportion in a sample at least as small as 37.5%? So to calculate that, we'd have to know something about this distribution. We've checked the success-failure condition, so we actually know that this distribution is normal or nearly normal. So I can use a z-test or a z-statistic in order to test this hypothesis. So in order to find the area to the left of 0.375 in the null distribution, I can simply find the area to the left of negative 1.84 in the z distribution, because this test statistic is the z-score for this sample statistic. So in order to find that area to the left of negative 1.84, I'm going to use Python. So I open up Python here. And the package I'm going to specifically use is scipy. So from scipy, I'm actually going to import stats. And then in stats, there's actually a method called norm, which is the normal distribution. So I'm going to call stats.norm. And then what I want from the norm is the specific method, the CDF, which is the cumulative distribution function. So I'm calling stats.norm.cdf. When I feed this norm CDF or norm.cdf method a z-score, it will give me the area to the left of that z-score. So I'm going to feed it negative 1.84, and it will give me the area to the left of that z-score. So the area to the left of negative 1.84 is about 0.03288, or roughly 3%. So basically what I'm saying is that the p-value is 0.03. So the p-value for this test is 0.03. And that's the area to the left of negative 1.84 in the standard normal distribution. All right. This case, we have the owner of a vegan eatery wants to test the claim made by a Gallup poll that 5% of Americans are vegetarian. So to this end, this owner of this vegan eatery goes out and samples 300 Americans and asks them, are you a vegetarian? And 28 of those Americans said that they were vegetarian. Now, because the owner thinks that the proportion is actually higher than 5%, that's what makes this a right tail test. Because if 5% is what the null value is, and we think that the proportion is actually higher than that, we're looking in the right tail of the null distribution for values higher than 0.05. So we go out and we collected the sample, and it turned out that 28 out of 300, the value of p hat, or the sample statistic, is 0.093. And with that sample statistic, I just found the z-score, and the z-score turned out to be 7.3 or 7.44. Now, because we're doing a right tail test, the alternative hypothesis is that the proportion is greater than 0.05. Because it's a right tail test, the p-value is actually the area to the right of the test statistic. Or in this case, in the sampling distribution, or in the null distribution, it would be the area to the right of 0.093. But we know the area to the right of 0.093 in the null distribution is the exact same thing as the area to the right of its z-score in the standard normal distribution. So I'm just going to go find the area to the right of 3.44 in the standard normal distribution. I'm going to use Python to do that. So here's Python. Once again, I already have imported scipy, and I've already called this stats.norm, but the stats.norm.cdf only gives me the area to the left. I actually want the complement, or the area to the right, so I'm going to do 1 minus to make sure it gives me the area to the right. And then the z-score I want the area to the right of is 3.44. So when I run this one, it's going to give me the area to the right of 3.44. And it turns out the area to the right of 3.44 in the standard normal distribution is 0.0002. So this is a miracle. This is a really, really, really rare event. So this is the p-value. This is the p-value, sorry. This is the p-value for a z-score of 3.44. So I found the p-value for this test. This right tail test has a p-value of 0.00029. All right, the last one I want to look at is this one here, where this is actually a two-tail test. It says a majority of Americans, which is 62%, say that trans athletes should only be allowed to play on sports teams that correspond to their birth birth gender. And what we did is we went through and we collected a sample of 80 people because we thought that the proportion was different. We don't think it's greater. We don't think it's less. We just think it's different, either greater or less, one or the other. And that's what makes this a two-tailed test. We're not concerned with it being extremely small or extremely large, just different. So in this case, the p-value is actually going to be double the area either to the left of a test statistic that's on the left of the distribution or to the right of a test statistic that's on the right of the distribution. So basically, if you calculate your z-score and it's negative, then you're looking at the p-value being twice the area to the left of that test statistic. But if you calculate a z-score and it's positive, you're looking at the p-value being twice the area to the right of that test statistic. So since my z-score is negative, I'm going to find the area to the left of negative 0.60, and then I'm going to double that to find my p-value. So once again, I'm going to go to Python. And since I'm looking for the area to the left, I'm going to get rid of this 1 minus because I'm actually looking for the area that the CDF is going to give me, the area to the left. And I'm looking for the area to the left of negative 0.60, but I actually want to do twice that. So I'm going to go here and do 2 times that so I can double that area. So when it's a two-tailed test, you actually need to double the area that you get either to the left or right of the test statistic. When I run this, I get that this is a p-value of 0.549. So the p-value for this test would be 0.549.